All right, guys, welcome to our asynchronous lesson for today. So we're going to start by just reviewing right triangles for our first three examples. When you look at the first example here, here's one thing that I want you guys to note. In this example, we have two sides that are marked as being congruent to each other. So this side is marked as being congruent to this side with these ticks. So I've asked you guys to look for these angles, but we want to remember that this is an isosceles right triangle. Our isosceles right triangle is another name for 45, 45, 90. Because a 45, 45, 90 is an isosceles right triangle, it has two congruent base angles and two congruent legs. So what I want to have you guys do now is I want you to pause your video. I want you to redraw your most basic 45, 45, 90 and solve for x. Solve for your missing leg. Alright, so hopefully you had your video paused and let's check your work. So again, your first step is to redraw your most basic 45, 45, 90. I'm going to draw my 90 in the same spot. I like my 45, 45, 90 because my hypotenuse is always my root 2 and my legs are 1 and 1. In order to find that missing x value, I'm going to match up corresponding sides. So 4 root 6 is the hypotenuse, root 2 is the hypotenuse. So I'm going to do 14 root 6 over square root of 2. And that's going to equal to the unknown leg, which is x, which corresponds to 1, x over 1. You have to cross multiply to solve. So I'm going to get root 2 times x equals 14 square root 6. Now our goal is to get our x value by itself. You're going to divide by root 2 on both sides. Now be careful. We want to remember that our like divides like. So I'm going to get 14, and then the root 6 and the root 2 are going to divide by each other to get square root 3. So you're getting 14 root 3. Like I said, check your answer against my work. Make any corrections. When I look at this next one here, I see that I have a side length of 8 and a 60-degree angle. Since I have a 60-degree angle, that tells me I'm going to use my 30, 60, 90. Remember when doing a 30, 60, 90, use your foldable as just a guide to redraw and label your side lengths. Go ahead and pause the video, redraw, set up your proportion, and then play it to check against my work. Alright, hopefully you have your triangle redrawn. You want to have your 90 in the same location. So according to my foldable, the side across from the 90 is always that 2. Now the 60-degree angle is down there. So the side across from the 60 is going to be square root 3. And then the side across from the 30 will always be 1. We're going to match our sides again. So the 8 and the 1 correspond to each other. And I'm going to write those as a proportion. And that's going to be equal to my unknown value of x, which corresponds with the square root 3, and I'm going to write that as a ratio in my proportion. I'm going to go ahead and cross multiply, and we get 1 times x is x, 8 times root 3 is 8 square root 3. Alright, the last one we want to learn how to find and spot is when I look, I have a 36-degree angle and I have a side length here. When I have a 36-degree angle, that's not a 30, 60, or 90, and it's not a 45 or 45 degree angle. So that tells us that we have to use SOHCAHTOA. So you have to use SOHCAHTOA. Alright, so when we're doing SOHCAHTOA, we want to start by labeling our hypotenuse with the H. So there's your hypotenuse. You then use your reference angle. So 36 is your reference angle. 15 is attached. Your x is opposite. Use this now to figure out your trig ratio and to set up your proportion. So after looking and seeing that you have your opposite and adjacent leg, I hope you recognize you're using your tangent. So it's tangent of your reference angle of 36 over 1 is equal to your opposite, which is your x, over your adjacent, which is 15. You're going to go ahead and cross multiply. 1 times x is x. 15 times tangent of 36. And you're going to go to your calculator. You're going to want to make sure you click on mode, that you're in degree. And do 15 times tangent 36. And you're going to get your answer. So you have 10.898. We went around to our second decimal place. So we see that the 8 will change the 9. So our answer is actually going to be 10.90. All right, so these are the right triangles that we're going to see hidden in some of the practice problems that we have to do. All right, so our next example, it's asking us to find the exact area of the parallelogram. You're going to want to scroll to your foldable. You want to find your area of the parallelogram. Your area of your parallelogram is to take your base times your height. Okay. So everybody, I want you to look at your picture, highlight your base, highlight your height. When you look at your picture, your base is the full length here. And I want you to be careful. I want you to recognize that that base is congruent to the opposite side. So your base is 18. 7 is just a portion of the base. Your height is here. You don't know your height. That's your unknown. So you're going to put an X. We're going to spot that right triangle in there. So this 7 is important because it's the side length of a right triangle, but it wasn't necessarily that length of the base. So we're going to use that now. When I'm looking, I see that I have a 30-degree angle. So since I have the 30-degree angle, I'm going to use my 30, 60, 90 triangle relationship to first find the height. All right. I'm going to draw my most basic 30, 60, 90. Okay, go ahead, pause the video and use your 30, 60, 90 as a guide to draw the similar triangle and set up the proportion to find the height. All right, so here's my 90-degree angle. I know my hypotenuse is opposite of that. It's 2. The 30 is going to go in the same spot. The side opposite of the 30 is 1. And my final side is root 3. When I go to match everything up and see what matches together, I see that the 7 and the 1 correspond. So I'm going to do 7 over 1. And the x and the root 3 correspond. They're in the same location. So it's x over root 3. And I'm going to go ahead and cross multiply. 1 times x is x. 7 times root 3 is 7 root 3. So that now means that the height is 7 square root 3. Now that you know your base and your height, you're going to go ahead and fill it in. So again, the height is 7 square root 3. The base is 18. So your area is going to equal 18 times 7 square root 3. Now notice that it asked you to please find the exact area. Exact means no decimal. So in your calculator, you're only going to put in that 8 times 17. and I keep saying 8, I mean to say 18. 18. So we're going to do 18 times 7. I'm switching it. 18 times 7. 126. Break down the root 3 and units squared. Okay. Our next example that we have is that we have a right triangle. So we want to determine the exact area of this triangle. Not a right triangle, just a triangle. All right, so we're going to go ahead. We're going to go to our foldable. We're going to find the triangle. We're going to look for the triangle relationship. All right, our triangle relationship is to take our base times our height and divide it by 2. So when I look at the triangle that I'm trying to find the area of, highlight the base. Okay, your base is 15. Now highlight your height. Your height falls outside the triangle. So again, watch the 7. The 7 is not included in the base. The 7 is a part of this right triangle here that you're going to use to find the height. It's a part of this imaginary right triangle. So your height is missing. So I'm going to put an X here. All right, since your height is missing, what we want to do is we want to find the height using our Pythagorean theorem. We know we're going to use our Pythagorean theorem because we have 2 sides with no angle measures. Go ahead, pause the video, do the Pythagorean theorem to find the height, and then plug it into the formula to find the area. All right, so hopefully we have our answer. When using Pythagorean theorem to find our missing height, we want to remember that we're going to use leg squared plus leg squared equals hypotenuse squared. The length of your leg, one leg is x because that's your unknown. Your other leg is 7, and that's going to equal your hypotenuse squared, which is 25. X squared plus 49, we want to simplify, equals 625. Subtract by 49 on both sides. X squared is going to equal 576. Square root on both sides, and x is 24. So you do that in order to find your height, which is going to be 24. All right, now to find the area, we're going to substitute in what we know. We know that the length of the base is 15. We know that the height is 24. And we need to divide that by 2 to find the area. You're going to go to your calculator. You're going to do 15 times 24 divided by 2 and plug that all in. And the area is going to be 180 centimeters squared. Our last 2 examples are going to focus on what we worked on yesterday, and that's working with the trapezoid. So we want to find the area of the isosceles trapezoid. What we want to remind ourselves about the isosceles trapezoid is it has these congruent legs that are right here. So what we talked about yesterday is those congruent legs help to create 2 congruent triangles, all right? So here's your heights, here. And then you get that other congruent leg here, okay? All right. So that's going to be important as we work to find the height. All right. When we look at our isosceles trapezoid formula, it tells us that we're doing base 1. Highlight base 1 plus base 2. We have base 1 and base 2, and then we're going to multiply it by these heights, which we already highlighted in orange, and divide it by 2. So we know base 1 and base 2, but we're having a problem where we don't know the height. And the issue is when you look at these right triangles, let's get this one. We only have one side length. We don't have an angle or another side length. So we have to figure out what to do. We talked about this being a rectangle in here. So here's this rectangle. So we know the length of the opposite side of the rectangle is 12. Now let's remind ourselves that these two segments here, down here and here, are congruent to each other. So what I can do is I can say, well, if I know the whole length of the whole length is made up of 3 parts. Equals my whole. I have 2 parts that are congruent to each other, but I don't know them, and 1 part that I know. I can go ahead and solve them. And I can find them to be 8. Now when I zoom in on this triangle here, that gives me 2 side lengths, and I'm looking for a third. So that tells me that I can again use my Pythagorean theorem. Remember, your hypotenuse is always across from the 90. You're going to get 8 squared plus 64 squared equals, you know what? I don't remember that one off the top of my head right now. 289. I was thinking something else. Square root on both sides, so that your x is going to be 25. Oops. Yeah, let me just write over that. All right, so now you have your bases, now you have your height. Go ahead and plug it into your area formula. Pause it, plug it in, and then I'll show, and then unpause it so that you can see my work. So the length of your bases are 12 plus 28 times the height, which is 25, divided by 2 is going to be our area. Remember to add that 12 plus 28 first, so you're going to get 40 times 25 divided by 2, and then you can plug that into your calculator. So you're going to do 40 times 25 divided by 2, and you're going to get 500 for an answer. So now we're going to determine the area of the trapezoid. So this is an isosceles trapezoid. It's a regular trapezoid. Take a minute, highlight your 2 bases, and highlight your height for me. All right. I'm hoping you highlighted the base here of 32, the height here of 9. I'm sorry, the base of 32, the base of 9. Sorry guys, I'm doing this late. And your height here. Your height is your unknown. Again, we are going to zoom in on this right triangle and use this to help us. Using the right triangle relationships that we practiced above, we're going to see that we have a side length and a 52-degree angle. When you have a 52-degree angle, that's going to lead you to Sorry guys, it just quit out on me. Give me just a second. And we're coming down here. Okay. So you guys go ahead, keep on writing out SOHCAHTOA. On yours, label your hypotenuse, your adjacent side, and your opposite side, and I will catch up to you. And you guys can check your work against mine. Here's your right triangle. Here's the parts that we need. All right. So we were saying we were going to use SOHCAHTOA. So let's check our hypotenuse. Our hypotenuse is always across from the 90. So here's our hypotenuse. We use our 52 to determine our adjacent and opposite. So the one right next to it, here's adjacent, here's opposite. Okay, take a minute. See if you can figure out which trig ratio you're going to use. After looking at it, we notice we have our opposite side and our hypotenuse. So that's going to lead us to our sine. When we set up our proportion to solve, it's always the trig function of the angle. So sine of 52 over 1 is going to equal the opposite, which is our unknown, over our hypotenuse, which is 26. To solve this, I'm going to cross multiply. 1 times x is x. 26 times the sine of 52. You're going to go ahead and put that into your calculator. And you're going to get 20.488. Remembering that second 8 informs what we do with the first 8. So we're going to round up 20.49. All right, so now I can go here and I can say I know the height, it is 20.49. Okay, you guys know the basis, you know the height. Go ahead, pause the video, take a minute to substitute in and check against my work. All right, so my bases are 32 plus 9 times my height, which is 20.49, divided by 2 will equal the area. Please remember to first do that 32 plus 9, and that's 41, times 20.49 divided by 2. We're going to go to our calculator. There. Okay, so I'm going to do that 41 times the 20.49 and divide my answer by 2. And our area should be 420.045. And our units are as inches squared. All right, so go ahead and check your work against the work that we did. All right, and then submit the asynchronous assignment for your attendance by 3:45 today. Thanks, guys. We'll see you on Thursday.